DEP is, I think what it's called, is it's executable digital echo processor, and we often just call it sounder. The interface you're looking at, you got your menu bar across the top and your display. Typically, you're always going to set up with, at least an echogram. If you've got a single transducer, I expect, Travis, you're set up with two, one for your down-looking transducer and your side-looking transducer. And you can set up your displays to either be target strength corrected, showing the target strength of your individual fish, or the voltage, the uncorrected amplitude. And most folks will do the target strength corrected. This is actually from that herring survey I just finished. I brought up as an example, and just got a little more pixelation and resolution on the data and voltage. For the, and again, the display screen doesn't really affect your data at all. It's just really how you want to look at it. You can toggle between, if you have multiple transducers, and look at 3D displays where your fish are in the beam, and it's kind of a gee whiz piece. Again, you're looking down the throat of the beam, basically standing at the transducer, and these kind of displays are really cool for ice fishing, and for your sphere calibration work. When you're doing field calibration work, they're handy. Again, you don't have to get that sphere right on axis to get target strength measure on it, but you're going to get your most accurate measures if you are somewhere close to the axis, or at least you're least influenced by noise. And it's often good when you're doing a sphere, just as an aside, to go ahead and wave it around a bit and just make sure you're positioning some echoes in each of the 4 split beam quadrants. Fairly rare, but did happen on the Colorado system, where actually there was a failure in the one of the electronic preamps, where it wasn't positioning in one of the quadrants, and then that puts some bias into your target strength estimates. Usually the displays that you have up for sure when you're collecting data are your system status window and echogram or echograms. There's a whole list of other displays that can be shown or displayed under the display menu. The 3D scatter plot is the one to the left. 2D scatter plot is the one that's showing down on the bottom center. You can have a digital oscilloscope. Some people find some value in them. They give a little quicker response than the echograms. Or you can look at things like background noise levels if you're grounding a generator and trying to kind of knock things down. There are some real-time fish density displays, or tracked fish by range, or angle off axis type of things that usually I don't bring up. You get too much going up there, it just seems like it's a bit hard to really track what's going on. And again, none of these really impact the data. If different people using the system, like say, as it goes to different reservoirs in Utah, have different preferences, you can save your screen under a view file that automatically gets loaded, and could certainly have a Scott and a Ryan and a George view file if just thought different things just got in the way. But in the end, doesn't really affect the data collection. It's just how you want to visualize it and see what's going on as you're collecting it. And your key pieces for a mobile survey, as you're kind of getting set up, want to network to I don't actually have an echo sounder here, so I won't be able to make these go live, but typically we want to be connected. We need to be networked to the echo sounder. This is what's passing commands back and forth and receiving data packets from the echo sounder. And then processing and saving data should also both be yes. And there's a toggle in here I can show later that if you check it whenever you're processing, it's automatically logging the data files. And I usually always want to do that because it's really easy to erase data files, but I have, otherwise your sequence is connect, process, save data, and it's easy to see everything start scrolling and get underway and realize at the end of the second transect that none of that went to disks. So, your other graphics are just really how much disk space you've got left. And for mobile surveys, you're always going to want to have a GPS unit interfaced, which HDI systems interfaces through the computer, through the COM port, or actually it will support USB GPSs as well with another little software add-in that'll just recognize your USB port as a COM port. But you always want to make sure you've got latitude and longitude numbers heads up before you start collecting data, because if you do, then they're going to go to your bottom file and then be merged in with your fish detections, which we definitely need to geo-reference everything. Yo.
Everybody I think uses just handheld GPSs for their lat and longs.
Uh-huh.
You don't?
I got a hardwired GPS depth finder unit.
Okay, so you're pulling. That's what I was wondering if you could hook it to that.
You can. It should support pretty much any, almost all GPSs that you'll buy will output the regular NMEA 0183 string series, and Dave, the programmer guy who put this together, I think he looks at a number of the strings in there. I mean, once in a while we've had somebody trying to use, most Trimbles I think it'll support too. We've had a couple where people were trying to do fine scale bathymetry and had a surveyor's grade, GPS I'd never heard of that. But for the most part, if you can, if it's got the ability to output data through a serial port, then you should be able to use it. So anyway, I'll just real quickly. So that's just kind of the display we're looking at. Once you're actually collecting data, we'll go through some of the setup parameters, most of which, once you get it set up for your survey of series or survey series, whatever, if it's repeating, you're not going to change. But if you do want to change parameters for whatever reason, you do need to stop data collection, with the exception of you can shift between bottom tracking or range tracking modes on the fly over on the left here.
When I like auto track the bottom,
right,
and then when you lose the bottom occasionally, then it stops collecting. Yeah, is that a glitch, or am I doing something wrong?
No, the auto bottom tracking, and we can kind of look at that as we go through the parameters. And in fact, even for this survey, which had some different substrate types. I mean, you're setting, and we'll look at that in a minute. You set a minimum voltage for the bottom and a window around it to track it, and it should probably work reasonably well on a lot of Lake Powell. But if you get into really irregular bottoms, or probably like some of the parts of Flaming Gorge where you just get a whole lot of relief change.
You know what I've got around that by changing that misnumber of pings. I just bumped it up big time. I think I changed it up to 50.
And that'll help too.
And then that grabbed the bottom, because I was losing it. It would say bottom loss.
Right.
That's what shows up in there.
And it'll go but then you're also not collecting anything.
Right.
And it's interesting, George, because that always bothered me too. And then I figured out what proportion of the whole
That's
transect
the thing.
you're
I've
actually
ignored
losing,
it
and it's
because,
like 1%.
Right.
Yeah, I've ignored it for a second.
Yeah.
It's just a little thing.
It's a little bit, but it is disconcerting.
Well,
that noise is so irritating.
Right.
When it's
yeah, sorry, and that's.
For me, it's always in real shallow is where I lose it.
And I lose it on the steep shore on the east side of Bear Lake.
Yeah, it's
Right.
Powell's got to be the worst, because that's where we lose it too, is in the steep canyon walls.
Right, and those are really tough. And and even on this survey where there was some relief changes and changes in bottom type, you can work with the bottom tracking parameters and often get it to lock well. It may change when you go to a different bottom type, or you can just set a fixed bottom under your setup bottom tracking. And I mean, you just
You don't want to do that for a place like Powell, because you're dropping hundreds of feet inside of a couple meters.
Right, but what you could do is just set a fixed bottom that captures the deepest location in your reservoir. You'll chew a lot more data, or you could do that in the background in this window here and just say, well, there's nothing deeper than
If I'm chewing the bottom down, then do we get into what everyone's talking about the windows?
You
about
shouldn't.
Tying up all my windows.
Yeah, you shouldn't. I mean, on this
Because,
survey,
I mean, I'm tracking pelagic fish, lots of.
yeah, and I think
then
there's-
If I'm also eating the bottom, is it going to be tying up my tracking windows?
it should not. I need to look back. I know Dave, our programmer, he did do some changes on kind of how the tracking windows were dealt with and the numbers that could be open. I think after we ran into the issue with the Colorado data. This data set we just collected, we ran 2-hour long files, typically chewing about 30 meters of sub bottom. We just fixed it
Right.
with a lot of fish we were tracking, and I've gone through the 2 weeks worth of data and it worked
Can you
fine.
tell me what the difference between auto acquire and auto is? I've always wondered that.
Yeah. Okay, I guess we'll just jump forward into bottom tracking because it's a good spot. So your auto bottom tracking settings only apply, if you're fixing a bottom, or manual, which is the
Right.
black knob on the front of the echo sounder where you can tweak it out. There is also an echo scope option, not a lot of people use, but if you bring up the little digital oscilloscope, you can just drag the little red ball bar and move your, it's sort of,
I've never done that.
it's the same. It's the same as the knob, but it'd be like
I
if
was
you
messing with the knob last year when we were doing our not ping pong. Now we have
a sphere,
a
right?
good sphere. But I was out there messing around. I was like, let's do some manual tracking. So I was using the knob on it. And
Right.
But yeah.
But anyway, that's one that's not. But the difference between auto acquire, if it loses bottom, it will search the whole water column on the next ping and look for the basically the next echo at range that has a voltage greater than whatever you set here. That has, so it has to exceed that voltage. So, I mean, one way to kind of look at that when you're going out and trying to set up auto bottom tracking parameters is just bring up the echo scope, kind of look at what your bottom voltage is. Oh, it's bouncing between 2 and 10 volts, so it doesn't look like it goes much below 2. Let's set it at about 1.5 volts. That should, kind of meet that criteria. Because the other piece it does, it looks for the highest integrated energy echo, that exceeds that voltage, which is typically the bottom. But if you set your threshold fairly low, maybe getting below 1 volt or so, you do run the risk of, if you have large dense fish schools or aggregations near the bottom, that's just going to walk up over them and track around them. So the difference being then auto, once it has a bottom lock and has set a window around it, it's going to wait and look for the next echo that meets those criteria within where that search window last was. And if, might be good in very gradual bottoms, but you run the risk of, you just stepped up out of that kind of domain and it may not get. And the reason...
So for George's problem then, it would be the better approach than doing what Scott said? Or
Well, I think we can look at what Scott said, because then if you extend this, if you're getting decent bottom lock to start and just put a big number in here, I don't know how big it'll support. Let's see if it'll. I don't know if it.
But you
But I
think
mean,
about it,
couldn't
that's
you-
only
Yeah.
a few seconds.
But couldn't you accomplish the same thing by just changing your window, your tracking window? I mean, if you've got cliffs that are 100 feet
Right, you fall off.
that you fall off of, maybe you change your tracking window to, 50 meters.
Right.
Is that going to slow everything way down?
No, it won't, but it has other implications, because
It won't track fish.
it won't track fish with it centers around the true bottom. So if you had a 50-meter bottom window, you wouldn't process any data within 25 meters. So,
You won't touch that one.
and the reason that it doesn't process data when it loses bottom lock, all this kind of hinges back really to the echo integration side more than the tracked fish side, because you're trying to get real-time estimates of fish biomass. If you lose bottom and it starts chewing a lot of bottom, that's going to contribute a huge amount of energy, and you're going to get just a really grossly inflated fish biomass estimate. So the logic in the real time and the tracking side of it was that we lose bottom, don't use those echoes till you get a lock, and then go. But Scott's solution is probably the better one.
300 pings was that? We're 200.
Well, if you're
So
at
that's
5,
1 minute.
if
1
you're
minute, right?
right, if you're at 5 pings a second, that's a minute.
So 1 minute.
So what would happen
that-
there would
I
be,
put 50, and so that's plenty because it usually will. I haven't ever lost bottom after I had it at 50.
right,
Just
But
leave it
the
like
thing
that
is,
one.
you've got a totally different system. I mean,
Right.
a minute at Lake
Well,
Powell
that's good.
is
Right, yeah.
but you know, and
Exactly.
what would happen here? I mean, I guess it would, you know, going back to maybe the steep dropping canyon, there still could be some issues there because it'll hold. Say you're at whatever 35 meters and it loses bottom lock. It's going to say, fine, carry on and keep trying to, you know, find something that meets that criteria, and then when it does, it'll you know, lock and track. If you had a long period of you know, it wouldn't start giving you that bottom tracking bleep error, but you know, internally it's still, where the hell's the bottom? I'll stay here until I find it. And that, I think for target tracking surveys, it's reasonable to set that max miss ping number up to a reasonable, you know, to a bigger number.
50 is 10 seconds.
Yeah,
Does that stay in the config file when you save it then?
Yep,
If you save
yep.
the config file, yeah.
yeah, that'll be in
So I
there.
have like the bare lake config, you have
Right.
Cleveland and Gorge config in there.
Right.
So we all have our own config
Right.
and all. I have my
Yeah.
own view file too.
So you guys aren't doing much post-processing then?
Yeah, I'm doing good.
They
Okay, 'cause
do.
what I do is if it loses bottom for more than a few seconds, I
Right,
give it a
you
few
take
seconds
it
to
down,
try it.
draw it in.
If not, I just hit fixed.
Right.
Then I've got that set to 70 meters.
Yeah, and that's
and
the-
it takes
that's
10
what I do.
seconds.
That's the
to
strategy I
process it to
usually
throw
do
the bottom
too.
in, you know.
And just connect it right
Yeah.
from where it was.
Right, because you
Where it
can
lost
change
it.
that on the
Yeah.
Where it
fly.
lost it
Yeah.
to- yeah, because it'll go like this, and then you'll see this
Yeah.
drop down, and then
Yeah,
you'll
and
see the
then
continuation.
big
Because I'm
lot
only
of
looking down to
noise
30
and
meters,
bottom
so I
and
just
stuff.
set it at 75
Yeah.
Right.
and I just hit fixed and then.
And there's not big issues if you're going through Echoscape. It's not a big time suck to just take the bottom edit tool and redraw. That's what we did on this herring data set.
Do you use it bottom
But
edit
that's,
and then just
I
redraw
mean,
your
that
bottom?
also is a bonus of Echoscape, because I remember before
But I
when you
like
spit
your
out
idea
the raw
of 50.
files. it
You
would
get
be
all
raw.
kinds of
I
false
hate when the
targets.
alarm goes off.
Right.
It makes me
Freaks
think
you out,
something's
right, right,
wrong.
wrong.
It,
You have to
It's
go into
usually
the bottom
3 o'clock in the
files and
morning
you
and
have
I'm like,
to.
It
Edit.
still will, you know, even with all the post-processing, I'll go through, make sure the bottom's all
It's
tracked.
always down
I'd say
canyon.
probably 1 out of every 10 transects still has one random point that's not visible
Lost bottom just for one ping.
at 510 meters, so it's real easy to just, you know, I pull all the data into Access to do the estimates, and then it's real easy
To see.
see. Yeah.
Yeah, and it depends on your system.
Yeah,
I mean,
it's-
the auto bottom tracking
it's
is
like
nice
one
because it
pixel
gives you
there,
a real-time heads up of your depth. And if it's working reasonably well for you, George, I'd just say, you know, run with it, but then off on the left here, make sure that this tracking is checked. Because if it's not, what happens is it'll go for, I don't know how long your sequences are, 5 minutes or something. You know, you just, you know, you say, oh, lost bottom, oh crap, you know, okay, I go over here,
Yeah,
pop down to fixed,
right.
and then it'll just lock on whatever that is, and you'll, you know, be chewing a little bottom, but can clean that up later. And then
Well, I
either,
just run over there and I go back to auto acquire or something and get it.
yeah, because you can do that on the fly,
Right.
or,
I'm not losing, you know, it's just a little bit.
yeah,
Because I hear the alarm boom, I know what to do.
well, and I'm
It's
with
just
you.
annoying sometimes.
Oh, it's totally annoying. Yeah, it is.
Out at 3 in the morning, you're like, no, something's wrong. And
Right.
oh, is that no problem? It's like,
And, you know, and then sometimes when I'm lazy or I just am in a hurry and it's dark and I don't want to spend a lot of time tweaking the optimum set of
Well,
bottom
I'm
tracking
trying to drive
parameters.
the boat, run to the back, check my GPS to get my transects. Then
Yeah.
I'll screw with the machine
Right.
by myself, you know.
you don't have a help ranges.
That time of year, a lot of times I don't.
Right.
Sometimes I got someone to drive,
Right.
but sometimes I run by myself.
So yeah, I mean, it'd be reasonable to do what Scott said, it's also okay just to fix your bottom beneath your greatest depth of interest and then just do all your
You're
post-process
fixing it
redrawing.
only- You're just flipping over, Ryan, and fixing it on the left side there instead of running the whole transect as a fixed bottom?
Yeah, if I lose it, I'll just flip it to fix real quick and have it fixed bottom.
Okay,
And just leave it at that.
And then you just flip it back.
and
The
probably,
only thing you need to watch is make sure that target box is checked, the tracking box is checked.
that will maintain it across multiple sequences. Otherwise, when it did a sequence switch, it'll look back and say what was said in the configuration file, and it'll flip back to that. So say if I was sampling, auto track in the bottom, and just like this one's set up, but I got into a spot, it's losing bottom, and then in real time while I'm collecting data, I just go over here, toggle down, click on fixed, then it'll be sampling to, probably sub bottom, but then at that next sequence switch, it would flip back automatically to auto acquire. Might be okay.
Which might be a good thing.
Might be
Yeah.
fine.
And that's
Then if you
usually what I
forget to
have.
switch
Forget it,
back,
right,
yeah.
it's only.
Yeah, if you
Our
if
sequences at Bear Lake are 6 minutes, and so, yes, after 6 minutes.
yeah, and
if
Bear
you've
Lake
got the
probably
flip-
auto bottom
flip
tracks
back.
well.
It
Powell,
tracks good, except on 2 transects where we got that really steep east side.
yeah,
And so I've learned to just slow the boat down a little
Right.
bit, and
Yep.
then once it catches, and then we start to level out, then I'll pick it back up. But if you slow the boat
Right.
down just a little bit, where that bottom is just falling
right.
off,
And what's
it'll-
happening there is that between pings, the bottoms,
Right.
if this was the example, the ping would be dropping more than 3/4 of a meter between pings, so it's outside the window and saying, "Oh, can't find it." And it might search and grab, but if it's continually dropping hard like that, you will get a lost bottom section. So, no, I like to use the, when you can really kind of get it dialed in, it generally works pretty well.
So then what was the difference between the auto and the auto acquire then?
I almost never use auto. In fact, I don't know that I ever have.
Yeah.
What would happen there, and apparently it kind of carries from how a lot of integrators were set up for marine surveys, it would only, you'd have a search window that lost bottom at some depth that had a window around it. It would keep searching till it found bottom within that window again.
Yeah. So if you lost bottom on one side of the reservoir, you might not pick it up again until you get to the other side because it's
'Cause
only
it's still
looking
looking in
a
the
meter
other
and a half.
Yeah.
on each side.
I mean, apparently it has some utility. I've never figured out
Parts of the reservoir
what.
that one.
But yeah, so I've just never used it. But so usually auto acquire. Manual I generally only use. I might use it if I'm doing a sphere test and want to just zoom out to just beyond the sphere real quickly and so on. We use manual for things like riverine or side aspect surveys where we're first setting up and running out to the far bank and just trying to establish what range we're really clipping things, and then usually we just then put that setting into the, because you will notice if you're using manual, the software is always polling that data pot, and there's apparently enough digital fluctuation in the little readout that sometimes you'll see a little bit of stepping in the range, but if you set it to
Yeah,
fixed,
and
it's,
we do fixed 50 meters for
yeah,
our side.
yeah, so it should be, rock solid. And
And then that bottom window, I've tried tweaking that, but I found out if I go to manual bottom tracking and look at my oscilloscope, because we still run this with an oscilloscope,
right,
and I'll take that thing, I think I could do a better job than the computer of getting it close to bottom. And so I was messing around during the daytime last year, and I was like, let's see if we could track some of these lake trout that are sitting on the bottom. And so I was like sitting there watching it,
right,
and you'd see the signal, and I was, putting that like vertical line on the manual bottom tracking. I was trying to, so you'd see a signal shooting up here, a voltage signal, and you see the bottom voltage, and I was trying to keep that line right in there,
right,
trying to pick off those lake trout. So instead of telling the computer to track with a bottom window of 1 meter, which is a half meter above, I was just doing it by eye, where those two signals were trying to split them. So I was clipping some of those lake trout. I just wanted to see if I could count some on the bottom.
right.
Just for
And that's exactly what we did on that ice fishing with the lake trout. When I was on the phone with you and the tent blew off.
Right, right.
That's what you were telling me. To
Right,
do.
because depending what your window is,
So I dialed it in, and yeah, it does
Yeah.
reduce the
and that's
It didn't reduce it enough for that.
no, not enough for that, but certainly this bottom window, I mean, you could see in this one, anything within 3/4 of a meter of the bottom just wouldn't be recorded in the data set. If I did fixed and then very carefully mark the bottom, then my limitation is really just that C-tau over 2 pulse width or the shadow, basically kind of those two in combination, which may approximate or come close to sort of that sort of thing. Okay, well, I think we've got bottom tracking kind of wrestled. I guess most of the folks know these. Oh, you got a dynamic one going there. Everybody, I think, knows most of the other settings. The configuration menu, once everything's configured and saved, it'll automatically come up in the last configuration used. If you've made changes, you'd want to save it on this survey. If I had, variations along the line, I'd usually just change them by
Make sure that
date.
config is the one for your water. That's
Yeah, if you're getting something that's come off of, because there are, certainly differences in ping rate and things that might be in effect. We'll talk about this later, but on the newer generation echo sounders, if you chose to collect that samples level data, the stuff that currently would go to your DAT tape if you're recording it, there is the utility in the new DEP to play those back, scroll them through, look at the data you just collected, although we don't support processing of it within Echoscape, but that's really the only difference there.
Wait a sec, so the stuff that's streaming to the tape is now also being streamed to what, flash memory or something?
You can
and then-
store it to a file on disk, yeah.
Cool.
So
Yeah.
you wouldn't
How
use
big
that,
are
you
those?
guys would need to use that.
Not if you're
Did you say
collecting.
there was an upgrade in the Echo Sounder itself that needed?
Yes, unfortunately so.
Okay.
It's not a pure software
Not just
one
the
because
software.
what's in the Echo Sounders, I think most everybody's using, and still the ones we have in our lease pool, it's a DOS computer is driving it, and that's where the whole Lantastic piece came in, which was, the best networking protocol to use in the 90s on that, but then they just really haven't, that's the limitation. I think we can still buy copies of it, but it's just, it's kind of they just don't support it beyond XP, so that's the one piece on the upgrade that's a, kind of a significant capabilities one. View files, I think we talked about that, just whatever the look and feel of your screen, however you want to shape it, you can just store and have as many of those as you want. I think everybody pretty much knows this real well, where you'd set the ping rate, whether you want to sample 1 or 2 transducers. You can also, if you're sampling 2 transducers and you've got big differentials in your ranges, again, your ping rate that you can, for target tracking studies, it's usually advantageous to run as high or a fairly high ping rate, just to get as many echo returns from individual fish as we can. It maximizes our detectability and number of target strength measures, but you can split the time that it's firing and then listening for that other transducer, asymmetrically if you have a really long side-looking range and working in a really shallow system to where you might want to have a higher effective ping rate on one than the other. You can do that in that software. But really, here's where you just set mainly your ping rate, your output file name, and then your sequence intervals. And usually, for most of our mobile surveys, we're not really all that concerned with sequences. The main thing that comes into play in the data is for echo integration, because we're integrating pings, ensembles of pings over some depth and time slice, and if we want to get real-time echo integration results, quite often we don't want to have one number for an hour-long transect. We'd like to maybe represent it in half-meter depths by some short times, but so a lot of times for target tracking, just because every time it switches, of course it's going to beep. It does a little beep, and sometimes it's easier just to have a 5 or a 10 minute interval, and you're just repeating the same sampling scheme as you go along your transect, and it would put in a sequence stamp with a time and GPS location in the data that you could look at as you're running it through Echoscape. Everybody knows that one pretty well. And again, most people don't. The main time you might go into transducer assignment would be if you'd had a new laboratory calibration done, or conceivably if you'd done a series of sphere tests and said, this thing's 2 dB off. I'm getting the same result. I don't quite know why. It looked, HTI did the sphere test 3 years ago. It looked fine at their thing, but in a case like that, again, you could just, if it's a small difference, you could just go ahead and collect your data, do a post hoc correction to your target strength. But we've also set a threshold based on this. It's going to be the smallest size target that we're including. If you don't have a high noise system and can set your minimum detection threshold well below your, say 6 decibels below your smallest fish of interest, you're fine. You've got some forgiveness there. You can always filter up later in post-processing and just dump those smaller fish not of interest. But again, that would be the time that you might make an adjustment. And if you were going to make a sphere adjustment, say I expected a minus 39.5 dB on my sphere, and it was consistently coming in, just for the sake of argument, say small, minus 42.5. Well, it's a 3 decibel difference. It's enough maybe for me to be concerned about and make an adjustment. I usually make the adjustments down here on this 40 log gain number. I mean, you could correct on either side. You could go, in that case, okay, the sphere is 3 decibels smaller than theoretical. Okay, so my system is less efficient than the calibration predicts, because the sphere is being calculated as smaller. So that would be going more negative on the receiver gain. So if I was to adjust that number to minus 164.65, rerun my sphere measurement, it would come out at minus 39.5. I don't recommend doing, there's always, usually we say if you can kind of get your sphere result within a decibel and a half of theoretical, and there's even a little forgiveness around that. I just leave it alone. But if I'm consistently getting a sphere result that's offset by 3 dB, I'd say it might be where I might start to get concerned, and I might make an adjustment. And I did do that here.
So what menu was that calibration parameters under? Which pull-down menu?
It's actually under transducer assignment, and then I just clicked on it. In fact, we can actually.
Yeah. Sorry, I just.
No worries. It's good to know. But really, the main time most folks go into these, I guess I will just comment here. I did. We had some issues. Basically, a transducer just croaking out on us right as we were heading out to do these surveys, and of course we've got a big lease pool, and I just went and grabbed the next one, but the shop guys were like, hey, we're busy, there's no way in hell we're going to deal with another calibration, you're leaving tomorrow. So I took the most recent calibration for this transducer, which was a couple of years back, with a slightly different cable length, went out and just did some careful sphere work, just a hour's worth of stuff, and then made a note down here in this one that I had adjusted that value to, I'll get minus 39.3 is just where I kind of lined in on it. And then we did come back and do a post survey laboratory cal, and it did spec right in with.
You're doing good in the field.
I done good, so I was happy about that. But anyway, so for the most part, what you're going to do here is you've sent, or we can set these up for you too and update your configuration files. But if you had a 2014 cal and we didn't have the computer or hadn't set it up for you, and just sent you the cal file. Here's where you just pick it up and attach it, and then it would just update. And this is all cryptic stuff, right? But basically, it's just showing the power output of the transducer, the pressure, at the different transmit source levels. We usually always run it at full transmit in open bodies of water, because then we're putting the most energy we can efficiently into the water.
So when you're calibrating that, or whoever calibrates that, and you're calibrating on that barge, do you pick up any interference from other people around you, or boats or anything when you're calibrating that, or does it have to be a real quiet environment?
Well, at times, and there are like some. Once in a while, they'll have like a Navy ship in across the cut that's running some test on God knows what. But and you will see some, you'll see some energy kind of pulsing through. So, and then they were close to the locks, and then on Fridays, a lot of times you'll just get a lot of boats streaming through, and actually as they're getting into some of these different kind of broader band sonars, so sometimes they try not to do the calibrations on Fridays. But so yeah, I mean, you can.
I was just wondering if there was something like that, like we don't calibrate on the weekend when everybody's out. Or
right. I mean,
my question. That's true.
I mean, our tech, Chris is usually the guy doing them, and he's pretty savvy. And we're, these have about a 6 meter separation between the test transducer and the others, so they're looking at relatively close ranges, and he can usually do a pretty good job of it. And then we always back these at the end of it with sphere measurements that need to check out against theoretical, just to give a benchmark going forward. So I mean, if he really was off, it would show there and he would redo it. But they can have impacts. And I mean, if you just look at a given transducer, we'd expect it, just like the speaker, if it's efficient, to have kind of a linear response as we increase power. So we punch up the power output by 6 dB, factor 2. We'd expect that power output, that source level, to go up by approximately 6 dB. It does there. Again, and up another 6 dB. It looks like we're about 5, so we're starting to tail a little bit, and then all the way up to max transmit. So there, that one is starting to roll off. I still used, and it's okay. They actually do calculate, and these are hardwired. There are ways to change them and blow up transducers, but they put in kind of the max power handling characteristics of that transducer, so that in that case, and it's more for big marine systems where you can put enough power into them. Certain transducers that you actually could, blow the ceramic or delaminate the ceramic. But for our stuff, it's generally not an issue. But so this one, it is starting to tail off, mainly on real high frequency transducers and the big high powered echo sounders. You might see points where you're going up in gain and really just not getting any more power out of the transducer. But I always, on the 241s, run them at 20 dB watts, and then it basically gives the receive efficiency, how efficient the transducer is at converting that voltage back into, or that pressure wave back into a voltage. And then all these series are beam fit coefficients that relate the measured, what they call the electrical angle. It gets a phase return that tells it how far that target is off axis, relating that to the actual, true physical angle off axis. So I don't need to beat these to death, but you're really only going to go in here when you have an updated lab cal, if we haven't done it for you, or if you had good reason to change an existing one based on sphere results. And here I'll go into just a couple more things. I don't want to drag this too far into lunch. The other ones that are, I think the sounder one we all kind of know. We've chosen max transmit. Whether you want to chirp or not would be whether you selected here or a continuous wave or conventional pulse width.
What was the downside of chirping? I mean, should we just be leaving that on?
There really isn't a big downside to it. I usually, particularly, I guess in freshwater systems, it improves your signal to noise, so you can typically get, but it really only improves it for like non-reverberant noise like that. I don't remember when you were having that generator noise at depth, whether you were chirping or not. It's really good at dumping that kind of stuff. It didn't on that. I'm trying to remember that one. I think that case, or not, I told Pat it was good to ground the generator.
Right, we grounded it differently and that helped.
But I think normally we would ground to the hull on the aluminum vessel, and as I recall, I think Pat run a ground lug right from the generator to the back of the echo sounder.
Right.
Yeah, which then just basically gave a noise path into it without a ground, because there wasn't a ground. It was just whatever was feeding from the generator, right?
We had all those issues, remember, too.
Yeah, we had some.
We just did all sorts of stuff.
We
Even laying the cable, when it was laying over we have spools where we do the trawl. So
Right.
we were laying that cable on the trawl and then it was going in the window and that was picking up a lot.
Really, yeah.
We had to put a boot, the rubber boot into the.
Right, and usually that's more of an issue when you really need to look at really small scatterers and you're just working down close to the noise level. But spools of cable can basically just act like inductive coils if you have them over an inboard and the alternator racking away and that sort of thing. So cable routing can make a difference. Shorter cables usually you just don't have as much to really induct into, but.
I wrap mine in that foam now.
That foam.
Pipe insulation.
Okay, that's a good one too.
Yeah, that helped me on our boat. Cause it's
Did
an
it?
aluminum boat.
Yeah, and it can be boat specific. I mean, it's kind of a black art. That's where either bringing up the digital oscilloscope or having a scope.
So
Just-
when you run your cable back, you're just putting the foam around it all the way down, or just?
Oh, just wherever it's touching the
Wherever
boat.
it's touching.
Okay.
I just
Okay.
had, like 3 chunks of foam that
Since
I wrapped.
I'm on the floor, I found if I took my cable and I coiled it, it would give me some weird stuff. And so,
Oh,
Yeah.
I lay it all out.
so I lay it all out and just kind of snake it to the
Yeah.
back, and then.
It
so
can
I'm
really
not sure
it can really be boat specific. Sometimes I keep, I usually in my kit have a few leads of just thin wire with alligator clips on aluminum boats, and there is a ground lug on the back of the echo sounder you can click to. If you got a scope, just disable the transmitter and then just a lot of times you'll just get that sweet spot and everything just lays down, but it's and a lot of boats have no issues at all, so I think it
Yeah,
just
we got long cables and we coil them the same way every time right on the deck, and we don't have any issues.
Huh, that's weird.
But generators grounded, echo sounders grounded.
All that's grounded on ours, but it's still getting noise, so I just spread it all out and put foam insulation around it.
okay.
Boy, we'll have to try that foam trick. Well, assuming we ever get around.
Well, right,
Never see water.
assuming they don't just surplus your boat to Scott in the next couple of months, yeah.
We'll let you know when we lowball your boat.
Right. That's what I was thinking. You say you're in the market for a new boat.
to grab it.
Probably
Give me
find you a
50
cheap
grand.
one.
Just tell them you'll do all the surveys, Scott. Maybe you'll get a deal on it. But anyway, no, there's not really a big downside to chirp. I mean, but it won't give you any it won't necessarily give you any improvement if there is, like your algae and if you've actually got scatters in the water or reverberant noise, it's not going to gain you anything. But you're not losing anything. So we certainly used it on this herring survey. And in freshwater, if you do get these folks with the really broad spectrum echo sounders and so on, that you sometimes get transients through your data, it'll usually get rid of most of that. So
Yeah, it's, like we were talking the other night, it blows me away how all these new sonar units are coming out with chirp.
yeah, you got to
think it's going to revolutionize fishing.
right. Well, I guess the main thing it'd be interesting what they were using before. If they were using a big, because a lot of times they'll go with wide beam, higher frequency transducers, and then use a fairly fat pulse width to get down there because it's cheaper. It's just cheaper to build higher frequency, wider beam transducers. So, maybe if they, you brought chirp into that, then you could narrow down your pulse but still get enough energy in it.
So do you think it would make a big difference, like in an ice fishing scenario, with if you have several of these units around you?
You mean like
If
those
you had
Vexlar
chirp.
kind of things and different? You mean the?
No,
Oh,
I'm just saying from a recreational standpoint. If you were out in the water and you have several sonar units around you, it creates a lot of noise. It becomes difficult sometimes to read your sonar.
Yeah,
If you
it
have
should help.
chirp, it should clean out.
it should help you, and it's unless they use the same. If we get time, we'll have a little quick talk on chirp. But basically, what chirp does is you can have an up chirp or a down chirp. It almost doesn't matter, but you're swinging frequency within the pulse. Like in this case, it's a 10 kilohertz chirp. What just went on there? And so that means since it's an up chirp, in the way we implemented it, would swing from like 195 kilohertz to 205. Just within that, and then the returning echoes from anything you detect are gonna have that same frequency sweep signature. It goes through a matched filter in the echo sounder and then gets compressed back to the narrow pulse. But the stuff from the other sounders won't meet that. So unless they were using the same frequency in a similar sweep, so it should get rid of most of that.
It's funny, our depth finder on our boat it's a 200 kilohertz, 50 kilohertz system.
Right, pretty
and
common.
So if we have it on any of the settings where the depth finder's going, we see that constantly. With the chirp, it breaks it up. But
Okay,
we
you
try
still.
not to run the depth finder when we're
Right,
doing
I
Yeah,
don't
we just.
hydroacoustic.
Yeah, we try not to
We can go into a compass setting, which is good for running our transects because it gives us our bearing and
Right, we leave ours on.
our speed.
Yeah, we use ours for GPS.
Yeah.
We just reach around. There's the two plugs on the back, and luckily the power plug is the one that runs the compass and everything else, GPS, and then the other one is just a simple transducer. And so we plug the transducer in, get to where we're going to start. We come up to the depth where we're going to start. We're on the GPS point, and we just reach over and go blink, pull the plug for the transducer, so it's not giving us any noise.
Yeah,
But you should be able to select just 50 kilohertz.
we could. I like having it for when we have the depth finder going, and ours all goes into one plug, so we can't easily unplug the transducer unless you get under the dash. But it's not a problem because we just don't run with a depth setting. But like I said, the hydroacoustics will often lose bottom when we're coming up on the steep slope on the end of a transect. So sometimes I'll have the technician switch over just to confirm what the depth is
Right.
before we make that turn, just because our transducers are hanging.
Or you don't want to
Yeah.
bang.
No, it's funny, I should check the ice fishing stuff. I'm guessing we didn't have the chirp on then because we made some enemies, we'd be out there fishing, and of course if you're a
Blowing
division
them all out
outfit,
of the water.
everybody just assumes that you know where the fish are, so all these anglers come and show up and set up their sounders,
Right.
which then of course trashed our street, so I'd have to go over and boot them.
Oh,
And
right,
they get
right,
pissed
right.
off.
Oh, I bet.
It's like, keep the secret spot.
Yeah, those.
Yeah.
That's that assumption that biologists know something, right? But anyway, I won't go through this too much. You'll notice here, though, just going back to absorption, this was a marine survey. We were using 200 kilohertz, so we did dial in that absorption correction because it could. We were reasonably deep in some areas and in marine environment, but often we'll either leave it at 0 or I think there actually is an alpha, a measurable calculated alpha loss in fresh water for 200 kilohertz. That's about 12 dB per kilometer. So, you could see that wouldn't make a big difference. You certainly could put it in there, but at 100 meters depth, I guess it would make about let's see, it's a
1,000 meters depth.
well, at 100 meters depth, it's 100 meters down, 100 meters back, so you'd be about a fifth of that. So a couple of dB, could make a bit of a difference. So, I think that's on the back of those yellow HTI tabled books. I think it's 12.4 dB. So you can dial that in if you want to, but for most depths people are working at, it just wouldn't, again, we looked at our target strength variability, it's not going to make a big difference. So the other ones I'll look at, I think we've already kind of looked at strata definition, where we basically just put in the threshold, which through that acoustic equation, or reduced form of it, that's just based on our power output settings, the voltage of the smallest fish of interest that'll get logged. For target tracking studies, it wouldn't matter really whether you're collecting the integration data or not. These thresholds to the right and the scalars just apply to echo integration. And you can, for the most people, if they're just doing simple strata, you can just key in any changes, but you can port these out to Excel and change them and bring them back in also if you're doing something complicated. The echo acceptance angles, and I remember going through this with Scott way back when over the phone, and it was, you do need to remember, basically this is the degree, the measure in degrees, left and right of your beam axis and bow and stern, which really defines a square rather than a circular, that you're accepting echoes. So this would establish your sampling volume. Again, that also goes back to your transducer. You can't make a 6 degree into a 30 degree. The directivity just isn't, the sensitivity's not there off axis, but there is some flexibility within the beam patterns to open them up or close them down. I mean, sometimes for horizontal, I've done things in rivers where we have a lot of surface clutter or bottom clutter, where I'll tighten it up a little bit on one side and not the other.
So on the ice fishing stuff, in post-processing, you tossed out targets that were more than, I think, 3 degrees off axis.
Yeah, just
trying to clean up the noise. But we could have done that if we'd known ahead of time. We could have done that just by dropping those down.
you could have. Now it's almost better to do. It's kind of better to probably leave these fairly wide, and you can see this was nominally a 15 degree transducer. I actually cheated it a little bit, and there's maybe some reasons for doing that when we actually look at target detectability for tracking. But if it was wanted to just fit it to a 15 degree volume, I'd make those minus 7.5 plus 7.5, and then the same. I guess this would be port and starboard, bow and stern. But when Scott and I were going through that, remember, Scott, I kind of gave you the numbers, and I think you didn't have the negatives, so we basically had defined just one point in space where it would accept echoes, because they both were positive. It's not getting any echoes. We went back and forth. I think we talked those numbers. I finally negative. Oh yeah, works great. We're good. But yeah.
Good to go.
And in the same way, I mean, the default, we talked earlier about just maybe optimizing target strength measures. A lot of times I'll even collect data where I won't even turn on pulse width criteria at all. Just again, if you're using an echoscape approach, trying to keep things open and just getting all my echoes above some threshold. But usually as a default, it's reasonable. The default boundaries, again, chirp, our pulse width is actually 0.18 milliseconds, essentially 0.2. The default is to kind of go plus or minus basically 50% within the closest digital sampling unit. And that's pretty wide. I mean, I wouldn't expect valid single target echoes from distributed fish to be coming back with pulse widths that are more than 50% larger or smaller than what I broadcast. Typically your narrower returning pulse lengths are from noise, things like electrical noise, spikes, that sort of thing. Your wider ones would be from overlapping fish, for the most part, or fish that are in close proximity where their echoes overlap and then extend. So, I'm not going to go much longer. We got to go to lunch. But you can collect things wide open, and then as you go through Echoscape, just apply filters and reapply, or if you wanted to look at your best echoes for target strength estimation. I might get more stringent on what I accept as a single target echo and limit to the center of the beam, and then those would be my best echo estimators of the fish target strength. But normally when we're collecting data, we want to be pretty liberal at what we're letting in the data record, because then we've got the ability to really explore and filter it later, rather than saying, shit, gotta go back to those damn tapes. So we don't probably have to go too much further. I think everybody else knows kind of the basics. GPS, if you've got a computer with an embedded COM port, it's normally always COM1. If you're using one of the USB adapters, it might be some other number, and you'd have to go in under the Windows system device hardware and just make sure what COM port it was, and then.
So that one below it, right there, store all data to NMEA. What does that exactly do? Is that
that was really put in there, and I think there were one or two users that wanted to look at some other data that's recorded natively in the GPS stream. So this just streams the whole verbose incoming GPS serial data string, everything, to just a text file. Not really all that useful for anything we're wanting to do, but the ability's there. And then this tells, I think he does give, Dave gives the ID of what he currently supports as external instruments, and if Andrew could speak to this, but just the different identifiers, and there's a lot more of them, I'm sure, but those are standard ones that you normally get in NMEA. And you can also bring in, again, we usually use this more on like riverine studies, although you could do it on a vessel for target strength measures or different sorts of measures. You can bring in, no, that's actually the rotators. You can aim your transducer remotely through software if you had it on a rotator. You can also hook up attitude sensors where it would be kind of pitch and roll and log that to the data, the orientation of the transducer. And that's really the guts of it.